All right. So Huddle01 is a video conferencing solution. It's Web3 powered, so it's basically for the Web3 crowd, and it's for all of you. So what we aim is to provide the Web3 native people a Web3 experience. So all of us owns NFTs, right? So you can use NFTs as PFPs, use them as a token gated feature, and do live streaming via live peer and many more features like these. So I'll be giving a quick demo of the product first, and then I'll show you how to build dApps upon those. And Arush here will go over the infrastructure that we have and will explain the architecture of Huddle. So yeah. So these are the features that Huddle01 provides you with. So these are the Web3 rich features that we have. So we have token gated meetings, NFTs as PFPs, decentralized live streaming, and decentralized storage as well using Filecoin. So I'll go over through the web app. One sec. So this is the meeting product. Once you land on the page, this is the lobby that you get. And over here, what you can do is that you can go ahead and connect your wallet first. I'll just quickly go ahead and disconnect it first. So this is the interface you get. And if you have a lens handle, you could go with that. Or like I'll just choose the MetaMask one for you. So once you do this, you get a signature request to connect your wallet. And once that's done, if you own a wallet, if you own an ENS address or a UD domain or any of these handles, you will be able to use them as your name. Or if you want to use a custom name, you can even enter that. So once that's done, you can just put an NFT avatar over here. We support Polygon as well as Ethereum for now. So if you switch off the video, you will be able to see your PFP. So I'll choose this one. All right. I hope I'm audible. All right. So once you choose your PFP, then you can join the meeting. So I've sent the request, and my laptop over here has gotten the request of the peer that has to join. So I'll just approve the peer from there. All right. So as you can see, the other person also has a PFP, which is an NFT, and you can even see that the other person has a ENS wallet. So it automatically got populated over there. You can even go ahead to huddle01.com and try it for yourself and give us feedbacks as to how you like the product. And you can even build like dApps like these using our SDKs, which we'll be going over now. So yeah.
Hi, am I audible? Am I audible at the end? Am I audible now? Fine. Can we have some energy? Can we clap, please? So I am Arush. I am a backend engineer at Huddle01. I'll now go and tell you all the problems I have faced building this product. This is a very sad story. Let's go through it now. So the main three problems that we faced while our competitors are Zoom and Google Meet. So first, building a privacy-centric platform. So if you look at it, most platforms are not. So basically privacy and security, performance, and a top-down economy. I'll go over all of these points in like three separate slides, and we'll go in depth. So first is privacy and security. So this is a very poorly made diagram, but I'll explain what it means. It might be hard to read, but I'll explain what's going on. So at the left, you can see there are like penguins. So this is the client. The client is sending the server a penguin over an encrypted channel. Now this is a transport layer encryption. So what basically transport layer encryption is, you take a pipe, okay? You put. Okay, I'm sorry, I got distracted. Okay, I'll continue. So let's say you have a pipe, okay? And that pipe, no one can see what's passing through the pipe. So it's like, let's say it's a PVC white pipe, you can't see what's going through it. So you send data through that pipe, server gets the data, and server relays that data to the other peer. That's how like traditional video conferencing works. So you send your video data to other people, that happens to a server and not directly. So you send it to the server gets your video and he sends it to like different people. The issue is most, like Meet, Zoom, most platforms which do real-time communication, which is video and audio, do not support end-to-end encryption. Why they do not support end-to-end encryption, we'll get to that. But they do not support end-to-end encryption, which means that the server, the pipe ends at the server. So basically we have two pipes, one from the client who's sending the penguin image. He sends the penguin image and the server, the pipe is ended at the penguin server. So the penguin is visible to the server. That means Google and Zoom are able to see what video you're sending. But let's assume they're very ethical about it and they don't look at your data. But it's like they have the ability to do that. They don't do that, they have the ability to do so. So that image is now relayed through another pipe. Now this pipe is very secure, but the issue is the pipe breaks. So what you do is, at Huddle01, what we do is, we take the penguin image, we encrypt it, then we send it to the pipe. So now we have a strong pipe which breaks, the pipe breaks. But because the image is encrypted, when the server receives it, it just sees gibberish. So if it's trying to guess if it's a penguin or a donkey, but it doesn't know what it is. So that's the whole concept between end-to-end encryption for all of us out here. That's a very simple definition. So now why don't people do end-to-end encryption for RTC? It is because it is very computationally expensive. So it has taken us research and some time. We figured out how to do this scalably, and depending on your client configuration, what we do is we pitch down the scaling, and we use different encryption methods depending on what system you have to send the encrypted data file to the server. So that is what we figured out for privacy and security. Second, moving to performance. Okay. So, how many of you all know how many data centers majorly do we have in India? Any guess? Like, how many cities might be having data centers in India? Any guess? 4 to 5. Any other guess? Okay, so the major cities which have a data infrastructure including Google and AWS is Bangalore, Mumbai and Delhi. 3 places. If you look at Africa, it's got so Africa is a very huge continent, but the number of AWS and GCP servers there, the data centers there are very less. So if you look at the image here, I've drawn a basic architecture to show you what's actually happening. So in case of Google or Zoom, they've got data centers everywhere, but data centers are huge to maintain. You need to put up upfront capital, get a data center to be able to do it. Let's say you're in some very not well-to-do country. There are very limited number of regions we have which have support for limited coverability in Africa. So there, if you're using something like Zoom or Meet, the distance between the server, as you can see, the person is in Africa, but I'm going to North Virginia as a server, which is in the US. So in case of Zoom or Meet, I would have to make that long jump. But I know that my other peer is still in Africa, but my packets have to travel long distances, which causes a lot of lag, packet loss, bad image quality. What you do is, we've broken that using our protocol. You can host your own nodes. And the more people you serve, the more you provide to the network, and that's how you earn. So that's the protocol we've been building for now, and that is how that is what the aim is. That replacing centralized servers with community-owned infrastructure everywhere. So let's say a school in Africa, for example, say a Zoom call. What they would do is they would host their own Huddle01 server, and they'll not only be serving to their school, but also they'll be serving to the people around them, and that is how they'll also earn in crypto, and that is how we'll compensate them. So here, as you can see, it's not a top-down economy where the businesses like Google and Zoom are earning money. It's the community who's serving the community, and because of the services you have provided, that's how you are compensated for it. So there is no unequal compensation for peers who are using the product and hosting nodes. So I think that is it. Okay. Now I'll just go through the technical architecture we have at Huddle right now. So that is the front end. So our front end is deployed via a CDN to all countries, so that when you go to app.huddle01.com, what happens is at the nearest edge location, I'll fetch the front end and you will have the smoothest, fastest loading experience. So that is our CDN. Then we have our own live streaming infrastructure, where let's say you want to record or live stream your call. What we'll do is we'll record the call, and then either we live stream via live peer, or we have our own live streaming service which can multi-stream to Huddle01 live streaming, which is our own HLS player, or Twitch or YouTube. And then we've got more streaming services coming in, like Twitter, LinkedIn, etc. Then for recording, what we do is we have our own storage service called Toothless. We have our cache hot layer, and like Ayush mentioned on call today, we store all our recordings on IPFS and Filecoin. So what is hot and cold layer basically? Hot layer is the layer where you want to fastly pull streams. Let's say you've just recorded and you want the stream just now. So that'll be on the hot layer, which has got faster downloads. Cold layer is basically a cheaper layer with slower downloads, but has high redundancy. So because it's stored on Filecoin, it'll be there for a long period of time. And this is the core of the product. This is the node basically, which we call the media server. We've got signaling here and media controller. These two components basically take care of the end-to-end encryption, the routing of videos that you send to me, I send to him, etc., etc. So whole handling of the node, basically, this is the node. That's all from me. Now I'll bring back Akshit and he'll go through the SDK architecture. Thank you.
Yeah, so I'll request you to take your laptops out now. And you can code along if you'd like, but I'll have to make it a little quick because of the crunch of time. But I'll briefly go over the SDK architecture. So as Arush explained, we have a media server involved. So when you use Huddle's SDKs, what happens is that you interact with our media servers. So that's being powered using the Huddle client, which you can see at the middle of the arrow. So Huddle client is the package that you install on your front end. And once that package is installed, you call methods on that front end using the client. And using those methods, you can then interact with the media server, which then interacts with the other peers on the network. So we'll quickly go over that. And as you can see that we have our CLI tool, which is Create Huddle01. So that enables you to create a Huddle powered app very easily in seconds. So I'll be going over that. And if you do not want to have real customization, like you do not want to customize your app at all, you can just use our Huddle iframes, and that are very powerful as well, which you can just embed in your own app, and then you can use your own app to power your meetings. So I'll go over that as well. So these are all the features that we have in our SDKs. So we have bundled the state management into our own SDK, so you don't have to create your own state management for the application. Then we have audio video media exchange, which will be powered with our SDKs. You can just call methods like enable webcam, disable webcam, and then you can just exchange media with that. Then you have NFTs as PFPs and all these. So yeah, we have 3 packages that we have at Huddle right now. So first is the CLI tool, which we'll go over first. And using the CLI tool, you can create these iframe powered apps, or the client, which is the web SDK powered apps. So yeah, this is the command. You can just type this out, and you'll get a prompt through which you can create the app that you'd like. I'd first go over the iframe one. So I'll just open a terminal. Hope it's visible. Yeah. So I'll make this a little bigger. So I'll just type in npx create Huddle01, And once you do that, CLI tool appears and you can just name your project. So I'll just name this for now. I'll say iframe, and I'll also add TypeScript because we love TypeScript. And once you do this, you'll see that in your directory, the app is created. So this is the example app. And if you open this up, you can see the app is generated, and all the configuration has already been done. So so it's throwing some errors. That's because the dependencies have not been installed. So you can do that with the package manager of your choice. So I'll use Yarn for now. So once this is done, then we can just run the app. And if you'd like to see like how all this works, if you want to go into much more detail, you can always check out the Huddle01 docs, which you can find on huddle01.com/docs. So it will be much more easier for you to understand. So it's well structured. You can read about that. And I'll just quit this call. Right. Yeah, so this is done. And I'll just say yarn dev to run the app, and we have it live. So this is the iframe example. So if you want to embed the Huddle app into your own app, you can do that. And via the controls that are present on the screen, you can control the app from outside of the Huddle iframe. So if you want to do something like, if you connect the wallet, then the meeting starts. So you can connect the wallet on your own web app and then just call the join method, and it will join the meeting inside the iframe. So we give you this power of using the Huddle app itself to power your apps. And if you want minimal customization, then you can use this. But if you want to go into much more detail and you want to create your own web conferencing app, like something like Omegle, so you could just use our SDK, install the SDK, npmi, or you could just use the CLI tool, which I'll be showing now, and use their methods. So yeah, this is the iframe example app, and we have both the TS and JavaScript versions for this via the npx tool. So this is it. Yeah, so if you wanna add the Huddle SDK to an existing app, rather than using the CLI tool, you can just install it via npm. That you can find on the Huddle01 docs as well. I'll just show real quick. So if you want to add to existing app, you just do yarn add. So this is Huddle01, so I'll show one sec. Yeah, so if you want to do it for an existing app for an iframe, so you could create a new route in your web application and then just add this dependency and follow this quick guide. It's just one page and you'll be good to go. That's that. Then we'll go over the Huddle client. So if you want to do for an existing app, you can follow the guide for that. The guide involves just you just adding the Huddle client and then going over just going over the steps of adding providers and stuff. I'll show you. So over here, I'll create the client application. So you just run npx create Huddle01 again. I'll name it the same again, and I'll say client and TypeScript. And once you do this, you'll have this app generated, and you can install the dependencies once again, and you're good to go. So once you do this, you'll have this app generated in seconds, and you can utilize this. So the instructions to use this example app, learn about it, are also written over there. So you can just enable webcam. It'll ask for the permission, and you can join a room. So the room ID for this is hard coded for now, but you can use your own room ID generator for that and handle that logic internally. So this is the example app, and I'll just quickly go over the code for it as well. And using the client SDK, what you can do is you can even utilize the live streaming and recording feature. So if you're doing it on localhost, then it won't work because the Huddle recording bot can't enter your localhost. But if you've deployed it, then you can utilize the recording and the live streaming features as well. So you could create a whole different app like any streaming app like YouTube live stream or something like that. And then, so I'll just explain the code real quick. So for initializing the app, what you do is that you first have to get your API key, just for the Huddle client. If you want to do Huddle client, then for to get your API key, you just head over to the docs, and we have this get your API key method. So you can connect your wallet. We don't use any smart contract calls over here. It's just for authentication. So once you do this, you can generate your own API key and use this. So I won't hover over it just for you to see. So if you do this and put it over here in the get Huddle client function call, then you will get a Huddle client instance. And using that instance, you can then access its methods. So this function over here called Huddle handle join allows you to join the meeting using this join function. And if you have your own separate address logic for your web app, you can use that to authenticate the user and then pass on the address for that particular user to be authenticated to the Huddle app. Once that's done, you just have to wrap your app inside the Huddle client provider, which gives your app access to the Huddle client instance anywhere in your app. So if you have separate little components, then you don't have to call get Huddle client again and get the client instance. You can just get it from the store or using the context itself. So once that's done, you can just call its particular methods itself. So as you can see, we have certain buttons over here. So these are instances of the Huddle client, and if I do control space over here, you'll get all the predictions for that. So we have different functions over here which you can go over through in the docs, and it's very easy to do. And if you have any doubts or questions, you can always ping us on the Discord or on our socials. So this is it, and what I'll do is I'll just copy this API key and show you. I'll delete it later. One sec. So if I put it in here and I refresh this and I'll join the room. So now I've joined the room. It'll ask for my mic permission, and then I can join using another tab. And once you do this, the other peer gets joined. All right. And you can do the recording as well, but right now I'm on localhost, so it won't work. But if you've deployed it anywhere, then it'll work. So that's all we have for the Huddle client. So this is the client SDK architecture. Like as I explained before, that we have our own state management. So you have this store that you can access. So if your app wants to get access to the states, like if is the cam paused or is the mic paused or not, you can access that via the store. And to use the store, there's a simple hook that is involved, a React hook, which is called use Huddle store. So you just call that and you'll get a store in return, and you can then access the properties over there. So that's how easy it is. And the Huddle client is then divided into subdirectories like store, hooks, and utils, and then schema. So if you're using TypeScript, then schema would be a good way to import the types and use them. And like hooks are like making your job easy. So if you want to fetch the stream or you want to do certain things, you can do it via the hooks. And utils are certain other utils, like if you want to get a track from the media stream, then you can do that, and so on. So what we did was that while building the Huddle app, we created this client SDK internally. So we follow a monorepo architecture where we created this client SDK internally and we used it and we got feedback on it. And based on that, then we made it public. So our Huddle app is also powered by our own SDKs. So it's a very powerful thing. So if you want to build a similar dApp like Huddle, you can do it via the SDKs and build a similar powerful dApp. So the store management is based on Zoostand, if you've heard of it. It's similar to Redux, but it's way better. Redux doesn't give you a lot of optimizations. So via Zoostand, you can prevent a lot of re-renders in your application, and it's really optimized. So we use that as our core for the store. And then we have our Huddle client context, which I explained, which gives you access to Huddle client instance in any component you want, and you can then use that Huddle client to call the methods, enable, disable audio, videos, and etc. So as I showed you, this is the Huddle client.join function, and you can just call it. If you're using your own wallet authentication, you can use that here. And this is the room ID, which you can generate on your own. And this is the hook that we use Huddle store to get the state in the store. And if you want to browse over the states, you can always head over to the docs, and you can find all the store states inside here. So that makes it very easy for you to use. So you don't have to create your own state management solution. So these are the data types for the store. We have joined room, then room ID, and so on. So these are the iframe SDKs. Like if you're building it from scratch, you can just install Huddle01/Huddle01 iframe and import Huddle iframe from that and just include it in your app. So that's how easy it is. And you can always use the CLI tool if you want to do it quicker. So this is the interesting part. So we've recently been experimenting with FVM, and like this is still in development. But using this, what happens is you can call the FVM methods using the Huddle01's web SDK, and what it will allow you to do is that all the meeting data that you have can be stored on chain. And then using that, you can then fetch data directly from the FVM. So you won't have to rely on us to fetch your own data. So this will be stored all on chain using FVM. So thank you. That's all from our side. If you have any questions, feel free to reach out to us, Akshit or Arush, or anyone in the Huddle team. So yeah, thank you. Any questions? Maybe related to the SDK or the app, anything? All right, cool. Yeah, for like storing the last part I showed you, the FVM part. So for that, we are using FEVM, which is like a Solidity smart contract, which gets stored on chain. So the meeting data goes on chain. Yeah. And then we have other features as well, like token gating. Then we have live peer. That's yeah. Right. So like if you have an NFT community or a DAO, so they have a token, right? So using our Huddle01's dashboard, you can create token gated meetings, and using that token, so you can just enter the contract address or the name of the NFT if it's popular, and you'll be able to create the token gated meetings in no time. Yeah. So yeah. Yeah, so if it's a token gated meeting, what happens is that in the lobby you connect your wallet. So if you don't connect your wallet in a token gated meeting, you won't be able to enter. But if you hold that NFT inside your like inside your wallet, then you'll be able to enter. So that's how it works. We also have our identity server involved over there to authorize authorize the user from entering the meeting. All right. All right. Thanks a lot.